This is your Unit 5, Lesson 3, Day 5 homework. This is number 9 on page 382. We are going to look at simplifying quotients of rational expressions in equivalent form as single algebraic fractions, then simplify the results as much as possible. So we're going to take a look at these quotients. So starting with number 9a, looks like we're looking at the quotient of 2x over x plus 2 multiplied by 3 times x plus 6 all over x squared. And the one thing we're going to do right away is we're going to take care of some factors. I think it's easiest to factor first, so then we can see maybe where factors get crossed off when we multiply and simplify. So you'll see right away on the top here, 3x plus 6, we're going to factor 3 out of this. And then this x squared in the bottom and right times x by x. So I have 2x over x plus 2, nothing to factor on the left. But on the right, we're going to factor this as 3 times x plus 2. And then on the bottom, we'll write that as x times x. So if we look at what's happening here for multiplication, we multiply across the numerator and across the denominator. So when we do that, the top would have to become just the product of 2 times 3, which is 6, and then x plus 2. And on the bottom, we would have x plus 2, which I'm going to line up well with the back end, and then x times x here, there, and there. And that takes care of all of our multiples. And then we'll take care of the simplifying when we cross off like factors. So this x over x is gone, this x plus 2 is gone on the top and the bottom. We're left with 6 over x. All right, and now what we have to know is that this is equivalent only for values that are not equal to 0, which we also know from here, but also where x cannot equal negative 2. That's how they're equivalent to each other. So let's try part B. In part B, we have 2x plus 6 over x plus 2 multiplied by 3 times x plus 2, or 3x plus 2, over x plus 3. And I'm going to do the same work I did in the last problem. I'm going to try to factor where I can. 3 and 2, nothing's going to factor out of this part. But over here in the 2x plus 6, I know a 2 can come out of 6. So I'm going to factor the left side this time to make this 2 times x plus 3 all over x plus 2. And we're going to multiply that by 3x plus 2 in the numerator over x plus 3 in the denominator. And then when this multiplies together, I'm going to save the extra step of rewriting it and kind of go to the multiply across the top, multiply across the bottom. This will become one big fraction, and the x plus 3 is going to go out. But we're going to remain with the 2 and the 3x plus 2 and then the x plus 2. So this is going to simplify into 6x plus 4 over x plus 2. Okay? And maybe you're looking at that and going, what about the x plus 2? Well, let's just check one more time. If I were to try to factor a 2 out of here, I would actually see a 3x plus 2, right? That was the top part here, not this x plus 2. So those are not the same things. What I do want to include, though, is that we also have to say that x cannot equal a negative 3 for those to be the same expressions. All right, on to C. C, we see our first division problem, x plus 2 divided by x, or x plus 2 over x. And then we're going to divide that by 3x plus 6 over x squared. When we do division of fractions, we have to multiply by the reciprocal. So we have to take this one here and reciprocate that. So the x squared is going to go to the top, the 3x plus 6 will come to the bottom, and then it becomes a multiplication problem. So we'll write that out, x plus 2 over x times x squared over 3x plus 6. And I'm going to treat it like I did in parts A and part B. I'm going to factor wherever I can. On the left, nothing to factor, but on the right, in this expression, x squared can become x times x, and then in the bottom, the 3 can be pulled out. So I'll leave the left alone, x plus 2 over x, but then on the right, we're going to simplify the top as x times x, and on the bottom, we're going to see this as go to 3 times the quantity x plus 2. So here now I can see the x plus 2 on the top and the bottom cancel off, and x from the bottom and the top cancel off, and I'm left with x over 3. As long as x does not equal a negative 2, and x cannot equal 0. Okay, part D. We have 2x over x plus 2 divided by x squared over 2x plus 4. Follow the same steps here. We'll take the second fraction, the second rational function, and reciprocate that to multiply. So I have 2x over x plus 2 times, whoops, I didn't write this out very well. This is actually 2x plus 4. That looks like a little squiggly y. On this part, 2x over x plus 2, we're going to multiply that by the reciprocal with 2x plus 4 on top and x squared on the bottom. At this point in time, I'm going to do the same factoring if possible. On the left, I don't factor anything out. There's nothing to factor out. But on the right, I'm seeing a 2x and a 4. A 2 can come out of that and make 2 times x plus 2. And on the bottom, I have x times x. So in this expression, I can cancel an x off, the top and the bottom. So this goes away and this goes away. I see an x plus 2 over on this side and x plus 2 over on this side. If I finish multiplying through, I have 2 times 2, which is 4. And on the bottom, I just have x. And we have to add the part that x cannot equal a negative 2. And we know from this expression that x can't equal 0 either. So we'll just put that qualifier there, that we can't have x equal to negative 2. And that ends question number 9 on multiplication and division.